Okay, number 5, this is the dreaded two-part SUVOT problem, right? Every single assessment is going to have a two-part one. They're all the same. I'll just give you this clue, right? So let's mark with red. There's part 1. In part 1, you're going to find the acceleration. So here's part 1. Coasts with a uniform acceleration from 92.5 meters per second to rest over some distance here. Notice that there's 1, 2. This is a 0, right? 3 numbers there. 3 numbers is what you need to SUVOT, right? So what we're going to do is we're just going to divide this into, step 1 is find the acceleration. And then the second step will be to use that acceleration to solve another SUVOT problem. Okay, so let's do this. S-U-V-A-T. Our final velocity is 0. Our initial velocity is 92.5. Whoops. There we go. Saved. Okay. Meters per second, right? And the distance is 624 meters. Okay. And then I'm going to use no t because I want a, right? So I'm going to do v squared is u squared plus 2as. Okay, so 0 squared is 92.5 squared plus 2 times a times 624. Okay, so now we're set here. Let's do this, okay? You end up with, by the way, negative, right? Because it ends up being 0 minus 92.5 squared divided by 2 times 624. Okay, so let's figure out the acceleration here. All right. Parentheses 0 minus 92.5 squared, right parenthesis, divided by parentheses 2 times 624. So if you do times, you better put the denominator in parentheses. Okay. Or actually make a fraction on your, like your TI-84 calculator, right? So my acceleration here, I'm going to write down a lot of digits. I'm actually going to store this in a variable. I'm going to hit stow and then alpha A. So 6.8559. Okay, it's actually 97. There we go. That's like way too many sig figs. And that's meters per second squared. Notice nowhere up here does it say calculate the acceleration. So that's the trick. Always find the acceleration. Now we're set. Let's go to blue pen land here and then solve the other SUVOT. Okay, so what was its velocity when it had covered only 200 meters of that distance? So let's think about this. I know we're going to use this acceleration. So the plane was decelerating at negative 6.85597. Okay. I think the initial velocity is the same one, right? Because we're talking about 200 meters. That's this guy, right? I think this guy is 92.5 meters per second, right? And then we want to find this velocity here, right? I do believe, yes? Okay, so it starts, the plane still starts off this way, right? So now we're set. We want to use a formula with no t. That's this guy. Okay, so let's just start plugging this in before my pen fails to respond here. Okay, so my initial velocity is, so the absolute value of v, right, is equal to the square root of, oh, that's a square root thing. Imagine that it is, okay. And then this is 92.5 squared, right, plus 2 times, and here's how we're going to get a less of a number, right? Negative 6.85597. I really could have said 68556 and been just as good, but I started writing it, you know, and then Okay, so let's draw that over. And then times S, which is 200. Sorry I'm writing so slow, but this pen is just like going crazy on me. Okay, so now we're set. Now we can just plug that into the calculator. I'm going to go second square root. And I have to type the left parenthesis there. 92.5 squared plus 2 times negative 6.85597. Now, actually, what you could do is you could actually store that in a variable and then just recall that. You go 2 times A times 200. Okay, times 200. I'm typing that in because that's what I've written down. And I get 76.2425 roughly, right? It's just a little less than 25. So 76.2 meters per second. Whoa, that's a 2 meters per second. Ta-da! For that, right? Now, the other possibility is that it's negative that. But since the plane's not like going back and forth, it doesn't really make sense. So only the positive answer in this case makes a lot of sense. There you go. So these problems, basically the pep talk is find the acceleration. That's going to be the first thing to do, right? Then take that acceleration, right, and toss that thing into your other suvat. You'll have to suvat twice. You're going to have to figure out which things are relevant, right? So for example, this guy here was our initial velocity here, found its way over there, right? Because it's the same thing. The airplane's hitting the runway at that, and then 200 meters after it hits the runway, we want to know its velocity, okay? So you got to think about these. These are a little bit more tricky than just sort of plug and chug, okay? Good luck. I will hopefully I can post some more two-parters up here.